I think we are back. That was enough break for us so that we can be able to proceed. Majority have been asking for a break of 5 minutes. Don't worry, we are by 6:10 we are done. Because being our first class, I would say it has been a bit successful. Even though majority have not yet watched, but we will make sure everybody get that one later. So as I was explaining on air hospital rule, and I was able to give examples. Maybe we can get more examples. Before now we look at air hospital limits applied in infinite. We look at, first of all, we take one more example, so that limit as x approaches 1 of x squared plus 2x minus 3 all over x minus 1. I think that one is correct. X squared plus 2x minus 3. So if you are given this one, and you ask find the limit of this one, we said you can be able to factorize that one. And when you are given x squared plus 2x, you will get x minus 1, x plus 3, if I'm not wrong, then x minus 1 absolute. The reason why I've decided to take this one is because majority of you have been asking on a situation where we have this one as an absolute. I said you handle it the way it is, but we will see that one when we'll be dealing with air hospital rule. So when it comes to air hospital, limit as x approaches 1. When we apply air hospital rule, you realize we said we differentiate the way it is. Limit as x approaches 1, but now you differentiate the way it is. You'll be able to get 2x plus 2. And when you differentiate the denominator, you get 1. So that now when you replace that one, with 1, you'll be able to get the answer is 4. You'll be able to get the answer is 4. But again on numerator, where we said we factorize that one, you find that x minus 1, when you talk of absolute, what does absolute mean? For the sake of you students who are asking about the absolute, I know you might find some books are saying a bit of stories, but we want to interpret it the way it is, as we agreed. We agreed we are here not to make your life complicated, but we are here to simplify mathematics, and that's why we find that our theme is that we want to simplify mathematics together. What is absolute? Absolute means that the value you will get here, if it is minus 1, it becomes 1. If you get minus 2, it becomes 2. So what we are getting here, will we ever get a negative number? No. We always get a positive number. That's why I'm using x minus 1. If I was expecting to get a negative number, I could have used negative of x minus 1. That's why you find that here is very simple. Limit as x approaches 1 to be x minus 1, x plus 3 all over x minus 1. So that one and that one will cancel, and you get the answer is 4. I said in case you have some doubt about something, you can use what we call the air hospital rule. So those are the basic questions that you expect when we are using what we call the direct substitution or limits applied in what we call direct substitution. Maybe I can give you another example which a bit complicated. Limit as t approaches 0, we have root t plus 9 minus 3 all over t squared. So when you are given this kind of equation over t squared, that is, you find that when you replace direct, you find root 9. So you get 0 over 0, which we said you cannot be able to replace direct. So we need to do some operation, one or two. So what we need to do with this one, maybe I'll solve this one here on air hospital, so that you see, if you find the equation is a bit complicated, you can be able to solve that one. So when we talk of air hospital, so it will be limit as t approaches 0. When I differentiate that one, I know that this was like t to power t plus 9 to power half minus 3 all over t squared. So that when I differentiate that one, when I differentiate this one, I'll get half, then t to plus 9 to power negative half times 1, because when you differentiate inside, you get plus 1 over minus 0 all over 2t. As you can see that one, I'll get that one all over 2t. And you realize that, again, when you replace that one direct, we may decide to replace that one direct, so I'll have limit. When I replace direct, I'll have 1 half 0 to power negative a half all over 2 times 0. So find that you get 0 over 0. So again, we will not be able to get the answer 0 over 0. So we can proceed to differentiate again. So have limit as t approaches 0, because we said if even after differentiating and replacing the value, you get 0 over 0, you differentiate again. So you have minus a quarter t plus 9 to power minus 3 over 2, because you minus 1 again, times 1 all over 2. All over 2. So now when you replace that one, you get minus a quarter 9 to power minus 3 over 2 all over 2. And I think that one, when you solve that one, you get, it is square root, so you get 3. So this will be minus 1 over 8, then 1 over 3 to power 3. And I think with that one, I hope that one we are good, so that you get something. But let's now solve this one by direct method. We use what we call by direct method. I'm assuming this one was minus a quarter. You check that one, because we differentiate the first time. It is root, so it is to power half. So you bring half there, it becomes minus half. Now when you differentiate again, you bring that one, it becomes minus a quarter. Then to power minus 3 over 2, because you minus 1. Then times 1 over 0, then 2. You get 2 as the denominator. So you solve that one, you get 1 over 8. Or when you get the square root, this is the square root, then cube. Power minus a third. So you try to solve that one and see what you get, but I'll come back to this one. So how do we solve this one? By direct method. So when we talk of this one by direct method, I know there are some situations where we used to find an equation like this when we are solving calculus by what we call the first principle. And I said, if you find this kind of equation, you might be solving an equation and you find that you are getting something like this. How do you handle this one? We agreed for us to handle this one, you can, if you have root at the numerator, we will multiply with the conjugate of that one. So in this case, it will be limit as t approaches 0. So I have root t plus 9 minus 3 all over t squared. But now I multiply with the conjugate. And the conjugate is root t plus 9 plus 3 all over root t plus 9, then plus 3. So that I'll have limit as t approaches 0. You find that when I multiply this one with the conjugate, I'll get this one squared. So I'll have t plus 9 minus, when I get that one squared, I'll get minus 9 all over t squared into bracket root t plus 9 plus 3. So I think at the numerator you find it is limit as t approaches 0 of t all over t squared root t plus 9 plus 3. So I think with that one the t will cancel out, one t will cancel out, so you get limit as t approaches 0 of 1 over t then root t plus 9 plus 3. I hope it is clear on that one how we solve that one. But how now do we simplify that one? I think with that one it will be very clear. When you solve that one, you get 1 over 0, which I think when I was copying my equation, I made a mistake. This was supposed to be t squared, so that this was t squared, this was t squared, so I was to multiply with the t squared. So here I'm getting t squared, again here it is t squared, so that here I'll get t squared over t squared, so that this t will cancel out, and here again inside it's t squared. So I'm saying my equation was supposed to be t squared plus 9, t squared plus 9, so I have multiplied with the conjugate, so it becomes t squared plus 9 minus 9. I wanted a situation where t squared will cancel out, so now I'll have limit as t approaches 0 of 1 over root t squared plus 9 plus 3. And when you replace your t with 0, you will get 1 over 3 plus 3, which will be 1 over 6. As you can see, the reason why we are getting that one is when you replace with 0, you get 0. So square root of 9, I'm assuming it is 3, positive 3. So positive 3 plus 3, you get 1 over 6. So if you have to check that one using El Hospital, we said my equation was t squared. We assume out there it was t squared. So you have half minus half, but here now you have, when you differentiate inside, you get 2t. You get 2t. And when you replace it with 0, you find that you get 0 over 0 because of this t. Again, you have to differentiate again. So remember here, you have to differentiate this one. Here you have to use the product rule. And I know when you solve that one, you get what we call 1 over 6. When you solve that one, remember here it is t squared. So that when you solve that one, you get minus a quarter. So it's a product rule. And I know after solving that one, you'll be able to get 1 over 6. Because we said El Hospital, if you differentiate the first time and you replace, you get 0 over 0, differentiate again. And when you differentiate again, you replace again. If it doesn't give you a specific value, differentiate again. And those are the kind of questions you expect. Even though after this one, I might be sharing the questions on the same, which are more related on the same. Even though our aim was to make sure we finish everything on limits, but due to some challenge that we underwent, we were not able to start the class at the time we are expecting, and our class was to end at 6. So due to those challenges, we were not able to finish, because I wanted a situation where limits are applied into infinite number, because I know there's a question where you find limit is applied on infinite numbers, and those are the kind of questions that the examiner will be very strict on, so that he or she can be able to test whether you have been able to handle limits, you have handled it very well. So maybe before we take more, or we wind up, I would like to take more examples on the same, so that I can look at questions which are within the topic that we have covered, so that we see the way forward. Maybe I can look at some questions. Someone is saying when you replace t with 0, we'll have 9. Where is that one? No, when you replace, because you get the root. There we have root. That is Amon Chebolet. Maybe you can somehow redirect your question, or you can set your question again. Felix, I think Felix is not a question. I think someone has answered Felix there. I can see a lot of questions. Maybe we go. I think majority are just complement. Yeah, someone had corrected me. I changed that one to be t squared plus 9 so that we can be able to solve that one. That is Lucas Odero. Maybe I'm not. Maybe I'm waiting for question and I can't see the questions. Can I get some people to raise more questions on the same? So that at least we can be able to see the way forward. Maybe, yeah, someone, Fadiri is saying, I think Fadiri, your name is common. I think it's based on the where we meet on the WhatsApp group. He's saying the last question, he has seen it a bit complicated, but I know with the issue of multiplying with the conjugate, it means that you practice more on how we multiply with the conjugate. Maybe I'll raise more questions on the same so that I don't leave some student hanging. Someone is saying about continuity. Yeah, someone is saying there's some questions he gave me on my WhatsApp. I'll handle that one later because what I realized that the majority of questions that I've been receiving on WhatsApp, the one that I found that I have not tackled was on absolute. I have tackled that one. Then on the questions of while you have limit as x approaches infinite, that one we have not tackled that one. But we'll handle that one later. Some are asking for more revision question. That is Paul Mwagi. I'll share that one later. Yeah, someone is saying we use the Air Hospital for the last example. I think I was trying to give you a hint on what you should do so that you can be able to finish on the same. Because I was saying if you had to replace this one directly, you find that when you replace direct, you find 0 over 0. So what you do, you differentiate. I have differentiated the first derivative, but we said you differentiate the way it is. One part, this, if it is t squared to power 9, the root of that one, you differentiate that one. Then 3, you differentiate that one. So I have tackled that one and I've gotten 0 over 0. So I said after getting 0 over 0, you need to differentiate again. So that after differentiating again, you check if when you replace with the 0, are you getting 0 over 0? If you are getting 0 over 0, you proceed until a situation where you get a correct answer. So that was my case. And I think with that one, we can call it a day. Majority are saying about the continuity. I have not tackled continuity, so that one we will tackle later, where we look at the 3 factors that you need to consider when you are testing whether a function is continuous. And kindly share more questions on the same, because the questions I received are very few. I expected a lot of questions so that I can be able to see where you guys are having some problem so that we can be able to tackle. I had all those examples. The examples I have had here are the examples I had, and those questions that I saw, they are relating with what we do. So with that one, maybe I'll give you more questions on the same here so that you people can be able to handle and answer all those questions. I think with that one, do we differentiate the first one again or we move on? We differentiate let's say in quotes you have gotten the first, even though it's not the first derivative because we are differentiating the way it is. If you find 0 over 0, differentiate again. Differentiate again, so that at the end of the day, we have what we call a defined value. So that one we will tackle that one when you will be handling the continuity. You see why we are saying you should get a defined value so that we can be able to say we have solved that El Hospital rule. Maybe with that few remarks, I want to end the class with the fact that majority of you, the majority I can be able to see majority of the students, that one will be in-house issues. I can see right now we only have 400 students, and my classes are having more than 600 students, so that one will be an in-house. We'll handle that one later. Maybe with that one, I can call it a day. But being our first class, I think we have done something. We expect next time to have no challenges so that we can be able to finish this one and focus on other things. Now, thanks you for watching.